Good afternoon, ladies and gentlemen. We've had very exciting presentations on the conveyor systems, covered conveyor, slurry pipelines, and railways. So I think it's only fit that I focus more on coastal shipping and inland waterways as a mode of potential transportation. The National Steel Policy has projected steel production to reach around 255 million tons per annum by 2030-31. And this implies that the raw materials that are going to be required would increase by approximately 2.5 to 3 times of their present production. This is an immense opportunity for growth because of the requirement in the downstream industries, that is the automobile industries, especially when India aspires to become a global manufacturing hub, and the Make in India campaign. And this will entail investments and requirements in the infrastructure sector as well. Same trend is expected in the Indian cement industry as well. The drivers of investment would be the national level programs like Housing for All, the Smart City program of the Government of India, the Make in India program, the construction of the roads and highways and railways. However, we see that India has one of the highest logistics cost as percentage of its GDP. It's estimated to be around 13 to 14% of the GDP, while for other countries like Germany, the US, and others, it's around 8, 9, or 10%. We need to address these issues, and some of the solutions that were discussed, like the slurry pipeline and the conveyor belt system, can help us address these problems. I would just like to take you through the present scenario. This slide shows the current modal share of steel transportation in India compared to other countries like Japan, Germany, US, and China. The modal share of roads, that's the blue bar, is at 47% compared to around, on an average, 27, 25% in other countries. And it's about 2 times that of Japan, Germany, China, and around 1.5 times that of the US. But we all know that road movement is economical up to around 400 kilometers, and beyond 400 kilometers, it's the railway that becomes more economical. And the average lead distance of steel, as per the studies which have been carried out, the average lead distance in India is around 500 kilometers. So there is a potential to streamline and address this issue of how to enable this shift from road to rail, especially when the lead distance is more favored and more tilted in terms of railway movement. A similar fact is also observed in the iron ore movement as well. In iron ore, the average lead distance is around 400 kilometers, and pipelines form a modal share of only 6%, whereas pipelines can address transportation requirements from anywhere between 50 kilometers to 400 kilometers in case of iron ore slurry. So this shows that we need to address some issues and have some more efficient modes of transportation. And also you would note that on the top, the waterways constitutes only 1% of transportation of the overall modal share for steel in India. This is when almost 60% of the total production is located in the eastern coast and near most of the major ports and other non-major ports in India. And many production and other consumption centers in India are located in the coastal areas, with the states of Tamil Nadu, Maharashtra, and Gujarat being the leading consumers of steel. This again shows that we can try and address this imbalance by using waterways and coastal shipping. This is a potential scenario which we can look at. The Government of India has already initiated the Sagarmala program. The Ministry of Shipping is the key agency involved in the implementation of the program. And the program looks at increasing the coastal shipping's share from the existing around 6% to 12% by 2025. For this, various initiatives have been taken, like policy level initiatives, cabotage relaxation, There are initiatives taken by the introduction of the Coastal Berth Scheme, which help in development of coastal berths, and other initiatives that I'll be coming to. The inland waterways has also got a renewed focus now, and I'll be talking about that as well in the future slides. Talking about coal, logistics cost of coal is approximately around 30 to 35% of the total production cost of power in our country. And the main coal fields are located in the states of Odisha, Chhattisgarh, Jharkhand, and the destination for some of the major thermal power plants in India is the southern states, especially Tamil Nadu and Andhra Pradesh. So we can, in fact, look at optimizing and, in fact, even look at considering coal swapping and change of coal linkages as well, where movement by coastal shipping or by waterways makes more economical sense. Although I would like to add that not all origin-destination pairs may be suitable for transfer to the waterway system. The other issue is the connectivity to the ports. We have already heard about the lack of rake availability at the ports. But the other problem is also that the Indian railway network is almost perennially congested as well. So we need to make additional investments in railway infrastructure in addition to having rake availability being made available at the ports. The Sagarmala program of the Ministry of Shipping aims to double the share of coastal shipping by 2025. We've had around 90 to 95 million tons of movement by coastal shipping. And it is envisaged by 2025, we would reach a number of around 220 million tons. The main driving elements would be the coal movement that is envisaged for transportation by coal here. Some of the key initiatives that have been introduced are priority berthing for the coastal vessels at the ports, discounts of minimum 40% of the vessels carrying coastal cargo at major ports, the enhancement of ease of doing business, reduction in the vessel turnaround times, faster documentation, then the introduction of the Coastal Berth Scheme as well, which provides grant in aid assistance to the states, the state maritime boards, and the port departments of the states for development of coastal infrastructure. Now I'll just briefly discuss the inland waterways scenario. India has around a total of 20,000 kilometers of potentially navigable waterways, and waterways as of now contribute only 3% of India's total transportation modal share. Recently, 111 waterways were declared as national waterways, and 5 waterways, the NW1 to NW5, are currently on a fast-track development mode. The Jal Marg Vikas project is being developed with the help of the World Bank, and the total cost is expected to be around 5,400 crore rupees. And the operating cost of the waterways is comparatively quite less vis-a-vis the road as a competing mode of transport. And one standard, around 2,000 DWT vessel, can carry cargo as much as 125 truckloads or full rake, depending on the infrastructure availability. These are some more details of the Jal Marg Vikas project, the infrastructure development plan, the multimodal terminals that are now called the freight villages at Varanasi, Sahibganj, Haldia, the multimodal logistics parks, ferry terminals to address the marine side infrastructure, as well as the ro-ro terminals. So an integrated approach is being adopted to drive forward the National Waterway 1 for moving especially bulk cargo materials, as we'll see in the next slide. This is the traffic projection in million tons for the next up till 2045. Coal is expected to be the main driver on National Waterway 1. Construction materials and minerals and chemicals would be the other key elements. So we have from Sahibgarh to Bar, we have a potential movement of coal. Then Haldia to Kolkata, Haldia to Kalughat, we have a potential movement of container systems here. From Patna to Bhagalpur and to the Kolkata Haldia dock complex, we have fertilizers or cements that can move. Food grains can be moved on the reverse return. Sahibganj, Patna, Talughat Bar, we have stone chips which can potentially be addressed. Then the Varanasi multimodal terminal can cater to cement, fertilizers, and other cargo for the requirement of the hinterland. Yeah, just the last slide. We've already discussed in detail the iron ore slurry pipelines. This is just a simple case study to display the cost economics. In the Chhattisgarh state, the Biladila mine of NMDC and the Raipur, the steel plants are there. This shows a comparative cost of movement by rail. Per ton, it would cost around 1,750 rupees to cover a distance of 860 kilometers by rail. Whereas movement by a slurry pipeline, it can be brought down to just around 390 rupees per ton. So slurry pipelines offer around 50 to 70% lower cost of transportation compared to other modes of movement, is comparatively more environment friendly, requires lesser land, and has favorable cost economics with a payback period of around 4 to 5 years. A capex would be around 4 to 6 rupees per ton per kilometer, and capacity can be anywhere between 2 to 30 million tons for a slurry pipeline with a length ranging from 50 to 500 kilometers. And NHAI has already granted the right-of-way for constructing pipelines parallel to the national highways. And what we have learned is that the Ministry of Railways has also granted the right-of-way for pipelines to cross the railway tracks below the ground, but the approval is awaited for movement for laying slurry pipelines parallel to the railway tracks. And as per the latest updates, there is a lot of research going on for movement of coal through slurry pipelines as well. So I would like to just leave you here with the key action areas. First is we should target increase the modal share of waterways, that is both coastal and inland waterways for transporting metals and minerals. And second is encourage pipeline-based movement of iron ore and explore the opportunity for coal as well. So I would like to end it here, and thank you so much for this.